Alright, time for another DraftPhysics.com, debatephysics.com also, but just can't get any physicist to engage in any kind of argumentation regarding the credibility of what they claim to be reality. And, yeah, it's unfortunate. They shouldn't be, cowardly. They should be proud of their physics and quite willing to defend it against the very few people who would argue that it's crap. And it seems the only people they'll engage are people that have really wacky flat earth style theories. But if they're challenging some specific element of their own physics, no, they won't bother coming close to that one. And so there's this other little channel I found, somebody, it's all admirable, trying to teach and explain and all that's great, but it's junk science, okay? It's really bad science. And the fact that they won't concede they really don't have evidence for what they claim to be true, and that they're overstating and exaggerating, and frankly, some of it's just plain silly crap. Bent space. Bent nothing is causing energy. It's heating planets. The bent nothing. Nonsense. Anyway, this is going to be a little bit on the photons and light. She did like a 3-minute video, which, frankly, 3-minute physics videos is just, that's garbage. Yeah, there's just no point in doing that. But anyway, that's what they do. And so, I'll leave us play the crap. It's just crap. I don't mean to be offensive, but it's crap. It's not science. It's not smart. It's not coherent. It's just a silly theory. It's burning bushes. It's just made up fable-y junk. All right.
Hey, Elaphysicist.
Can't quite hear that. That's weird. I should be able to hear more of that than that. Don't want the echo, but do need to hear her, right? Yes, we do need to hear her.
What's the crack?
What's the crack? Now, what the hell does that mean? So she said something like, she's like one of them, Irish, Scottish, part of the British Empire, but they don't really speak English kind of people. Anyway. So she says, hey, A-level physicist something, and then she says, what the crack? What the crack? What the crack does that mean? What the fucking crack does that mean? Ass crack? What does that mean? I don't even get it. Sorry. What the crack? What the fuck is that? I assume it's not a drug thing, but what the fuck crack are you talking about? Frankly, what the crack? So right there, I'm in trouble. I don't even understand what they're talking about.
So today we're going to do is waves, right?
We're going to do some waves. Okay, some waves. Okay, so this is a single slit. And there's not going to be any sign of any wave mechanics that makes any sense here at all. So the single slit is kind of obviously not comparable in the sense that the single slit in light creates a lot of fringe pattern. Single slit in water doesn't create any. And clearly she can't draw us anything called interference, so she just calls it diffraction, whatever that means. So it looks exactly like the interference pattern. Even the double maxima part is there. And she calls it diffraction, whatever that is. But she won't be able to draw whatever this thing called diffraction is. So it's just pathetically bad.
So it says we've got a single slit and we're illuminating it with monochromatic light. Just remember, monochromatic, mono means we're using a single wavelength, okay? So it's
right, so it's just the basics, so we won't get confused by all the colors.
It says what we're going to do then is we're going to make the slit width is increased. So we're going to make...
Right, so all it is just what happens as you vary the width between the two surfaces, the distance between the two surfaces. And what you obviously do, she just drew the triangles, is that you, create a lot more opportunities to have a vector from the two surfaces have a wavelength of difference. So, I suppose we'll have to draw it just for those who, like there is any new viewer ever to this channel. Just doesn't happen. Well, and, it's not happening for her either. I mean, you get just, 50 views. I mean, nobody's, YouTube is a closed media. The popular are popular and everybody else is nobody forever. Anyway, that's the tendency. This looks like it's way overexposed, but that'll have to do. All right, so you have a single slit. I could make that much bigger, really. So, all right, so single slit. And what's the key thing? The key thing for the mathematics is the distance between these two surfaces. That's the variable in the math. So that little formula, W lambda something or other over S, which is, I guess, the distance to the place you're going to view your pattern. And the simple argument is there's going to be vectors. You're just going to draw straight lines from both of these surfaces. Okay, that's all you're going to do. That's what the math is doing. It's just drawing these straight lines. Right? There's going to be places where there's a wavelength of difference and places where there isn't a full wavelength of difference. So the length of the line is exactly one wavelength of light longer than the other line from the two surfaces. So these are all just Pythagorean triangles and blah, 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 blah. And there's places, okay, where you're going to end up with a pattern. And this pattern can have, I've made a pattern that had like 70 bars. Let's just say 50 for the hell of it being not too excessive. But I mean, if you put these two surfaces far enough apart from each other, you can create a huge number of these distinct little fringe bars or nodes. And again, this is just like the double slit pattern, except the double slit pattern has both. It has the little ones inside of the big envelope pattern, and just tons of fringe patterns. So as Professor Lewin states, both the single slit and the double slit, it has to be the same phenomenon that's causing it. There's no such thing as diffraction versus interference. Now, he's a believer in Huygens, and so he'll say it's Huygenism in both circumstances. But the point is the two patterns are too similar in the single slit and the double slit to claim it's a different some kind of different phenomenon. And it's a fringe pattern, and it's going to be created by the same thing. And the only difference is this is the two source. The single slit is the two source or two surface experiment, and the double slit is the four surface or four source experiment. And that's the only difference. And this is all it's going to be about. It's these straight line vectors. Nothing interferes. You're just saying this something about the surface creates a phenomenon where there's components that arrive at a location, and now you have a photon using substance from both of these surfaces. Create an outcome where you end up with a photon hitting these surfaces. And so it's only the photons that hit the surface. And what she's going to isolate here is the fact that the wider you make the opening, obviously the more light that just goes straight through, and you end up with 95% of the photons in this tiny area, okay, right here, right straight through the middle. And the fringe pattern is obviously being created just by the photons that went near a surface. And it's just so obvious that's the mechanism. So what she's going to draw is just waves coming out of the single slit And you just say, there's nothing, there's no interference in one wave. One wave doesn't have interference. This one wave moves. There's no interference in there. There's no diffraction, whatever that is. So there's absolutely no evidence of anything capable of creating the fringe pattern. So I'm just illustrating how far off this is from anything reasonable as an explanation for the phenomenon. I mean, there's just nothing here. There's no good science. There's no good description of the physical reality.
The slit width bigger, and want to see what happens to the pattern on the screen. Okay? Just a bit of revision. When we've got a single slit, what actually happens is...
I don't know what the revision part means. So this is, terminology they use that I don't have any idea what the hell they're talking about. Could use a little more volume, I think.
Central point, which is equal distance from the two ends of the slit, is going to be your central maximum, your bright spot. Okay? And the width of that is always 2 times the width of the other fringes.
So it's not exactly. So again, that's just being imprecise. It's something less than 2 times. And the double slit proves it. Because the double slit shows that the nodes are like 4 or 3, and the center is always 1 less than twice that number. And it's always an odd number. So the center will either be 1, 3, 5, 7 little dots. And it's always a little bit less than twice. Okay. So she didn't get that right either. I mean, they don't care about being precise.
So your central maximum, and then remember the intensity drops further away from the middle. So then...
All right, so that doesn't happen either. So the intensity of the nodes stays really strong for quite a distance. And so there's, like I said, you can have up to 50 of these little bars, those little nodes, that are quite distinct and quite visible, and there's no evidence that they are in a dramatic way getting dimmer and dimmer. They obviously do. There's a point where there isn't any, but it's a rather dramatic cutoff. I mean, they all look the same brightness until you get towards the very end, and then they just tail off. Now, the argument is, from my perspective, that's because the light doesn't get diffracted. It doesn't go to those far edges, the 0 degree, the 180 degrees, that it actually doesn't create any pattern over here or over there. And that they've never tested for that by simply putting a detector on the tangential planes to see if they can collect any fringe pattern at those high angles. And of course, never done that experiment.
The width of these are all the exact same, but the central maximum, the width is always double the rest of them. Okay?
So, and it's also very deceptive to draw it this way because, frankly, I mean, technically by their theory, okay, the in phase and out of phase should be equal in proportion, and they're not. So it's quite obvious that the light can be quite a bit off in terms of it doesn't have to be perfectly in phase or perfectly to be still a photon, still detectable as a photon. So the dark bands are smaller than the bright bands.
So what this equation here is to find out what that W is, and then remember the central maximum is double that distance. So what we've done here is we're increasing the slit width. So S, our slit width, is being increased, and that equation is on your data sheet. If I increase S, I keep the wavelength the same and the distance between the screen and the slits the same, and figure out what happens to W. So if we increase this number, we divide by a bigger number, W will get smaller. Okay? So I'm going to write that down.
So all she's trying to say there is that the places where you can have a full wavelength of difference increases. So as you expand the base triangle, the number of triangles you can draw where you have a full wavelength of difference in the length of the lines will increase, meaning there's a higher density of them, so they're smaller. So she's using some they get smaller argument when the real argument is they get more numerous. Yes, incidentally they get smaller, but that's only because there's more of them in the same space.
W is going to get smaller. So what that means is all of the W's are going to decrease, so my pattern is going to get shifted in together.
So that doesn't happen either. So if you actually do the experiment, you don't see that actually, where the pattern itself gets small. It's just that there's more of it. There's more detail in it. It has more nodes in it.
Because maybe before this was 5 centimeters, but if W gets decreased, it's now going to become 1 centimeter. So it all gets shifted closer together. Okay. The other thing says was what happens with the brightness. Okay. So brightness, we're thinking about intensity. Okay.
So that's going to be the intensity of the experiment's always going to have a, it's this aperture issue. So the smaller you make the aperture, the hole, the more likely it is the photons are going to hit the surface. So the higher the percentage of photons that hit a surface, meaning you get lots of fringe and not much light that goes through without hitting a surface. And the bigger you make the opening, okay, obviously that changes, and lots of photons go straight through without being disturbed by the surfaces, and fewer photons are being disturbed by the surfaces. So now your concentration of light is, dominated by the photons that don't hit a surface, and the fringe pattern sort of disappears eventually because it gets overwhelmed by the light going straight through.
So I know that what happens here is that the light is diffracted.
So she knows this. Okay, she knows that the light is diffracted, which doesn't mean anything. She's saying photons behave like water. So water molecules are stuck to each other, and that's why they make that bulge, is because the water molecules are stuck to each other and they're dragging on the surface. That is, they're getting slowed down from the surfaces, and the slow ones are dragging on the fast ones and stopping them. So that's why you have a wave. And so all of that mechanics, you say, somehow is being duplicated with photons, that somehow they're being dragged, okay, and being forced to create a bulgy round front, a wave front, when no, all they're doing is creating vectors. Now you can have vectors that are equidistant and it'll look like a round line, but it's just equidistant straight lines. I mean, if I draw an explosion, I might draw it as a bunch of rays coming out, and you could draw a circle around each moment, each second, and say, okay, there's stuff here, and then in 2 seconds there's stuff, in 3 seconds there's stuff. And you could draw those lines, but clearly the crap flying out of the explosion is not waving. It's flying out in straight line vectors. The rays from the sun are that, rays. They're not waves.
As it passes through the single slit. I know diffraction happens with waves when the gap is either equal in size or less than the wavelength.
So if the gap is less than the wavelength, you're not going to get any pattern because there won't be 2 points. That's making the triangle very small at its base. Now you can't make any, pattern, because there's not a single place where there's a full wavelength of difference between the two lines. So that part doesn't even make any sense.
Okay, and that's when I can get the most diffraction to occur.
She gets the most diffraction the smaller the slit is. Does that make any sense? You get much more pattern the wider it is. So, and if I make it smaller than the wavelength, again, I'll get no fringes. There won't be any fringes. There's no fringe pattern in the single slit if I make the slit opening smaller than a wavelength. That only works in the double slit, because then you turn the 4 surface experiment into the 2 surface experiment, because you make these 2 points so close to each other that the 2 points, like headlights on a car from a distance, they just disappear. And so all you really have is 2 sources now, because you made these 2 so close together, there's no difference. There's no distinction between the photon coming off this one and the ones coming off this one. They're the same length of line, because you changed. You took away the distinction. So if I get rid of it this way, or I could get rid of it that way, but either way, if I make 2 of the surfaces too close together, I won't have the same number of sources. So what she just said here is just nonsense. If she makes the slit opening smaller in the single slit, then she's eliminated all fringes. There's no pattern at all.
So let's say the gap was super large. We're not really going to get any diffraction.
We're not going to get any diffraction. Do you hear what you just said? So the circumstance where you have more pattern, she's saying you have less pattern. Doesn't make any sense at all. I mean, it's completely disconnected from the actual physical experiment and what actually physically happens. And they just, you know, she's gotten nonsense from the double slit confused with nonsense from the single slit. And so now she's not describing anything even close. I mean, their nonsense on each one of those subjects is nonsense, but now she's made it double nonsense by confusing the two subjects.
Right? But if the gap was really small, I'm going to get loads of diffraction, loads of bending of those waves.
So just too silly, right? Again, if I close the slit altogether, you're not going to get anything because you've got no photons. I mean, it's just ridiculous.
Okay? So what we've done here, we've made the gap bigger. So what happens is we're getting less diffraction. So I'm getting less diffraction.
So the silly part is you're getting more and more fringes. So the wider you make it, you could start with something very, very closed, and you just see one blob of light. And then you start opening and you get 2 blobs and 3 blobs and 4 blobs and 5 blobs and it'll just keep going up and up the number of distinct fringe nodes. So clearly more and more pattern is created the further those 2 point sources are from each other.
I'm getting less spreading out of the waves. They're not spreading out as much. They're not diffracting as much.
So again, it doesn't make any sense. The waves, and she called them the waves, but there's only one wave coming out of the one opening. So clearly there's just nothing. There's nothing in this drawing. You can sit there and just look at it and say, what do you mean? How did you create these bumps with these straight lines? I mean, these contiguous lines. There's no interference here. There's no anything. What's it being created by?
Which means more of the light is going to hit the maximum. It's because more of the light hits.
So we know more of the light's going to hit the maximum because the percentage of photons that would be near a surface starts declining the wider the opening, and that's the only reason.
Maximum, that's why it's going to get brighter. Okay, so just to recap, if we increase the slit width, if I make S bigger, I've made W smaller, so the fringes are much closer together, and then
there's more of them, period. It's not just that they're closer together, there's more of them.
Because I've made the slit wider, I'm going to get I'm going to get less diffraction. So because I get less diffraction, less spreading out of the energy.
So again, more nonsense, less spreading out. So how do you not spread out a round spherical wave? You can't not spread it out. It's by its nature only one wave, one spherical wave. You can't say it's diffracting when it's this size, and when it's this size it isn't diffracting, because it's always going to be the same sizes. It's going to eventually be all of those sizes. So what's the sense of this? I mean, there's just no logic here. None.
I'm going to get more concentrated on the middle, so my central maximum.
So there's no concentration. You can't change. It's a round circular opening. You're just sitting there saying, look, it's a round wave. I'm taking this half of it. It's this round thing. How can I change it? Even if I make the wavelength smaller and smaller, it's still the same round wave hitting the surface. How is that going to create fringes?
Will actually be brighter. So that's grand.
Yeah, that's just garbage.
So follow me for more physics content like this.
Yes, well, if it's like that, then it's garbage. So yeah, not a great idea, frankly. But yes, physics is garbage. Okay, kinetic energy, nonsense formula, garbage. Wave particle, garbage. Gravity, bent space, garbage. No, gravity is an actual force. Just so bad. So anyway, yeah, that's all there is. Okay, so she's got one comment. We need complete videos of all one chapter in one shot. Please provide. Yeah, I'm sure. Commenters, they're just useless. No matter where you go, they're just so useless. All right, anyway, so enough of a video. Just a terrible description of the actual physical experiment and what can be easily observed by comparing single slits to double slit experiments and just looking at the pattern. And it becomes clear. It's a pattern created by point sources. The surfaces are point sources for the creation of fringes. It's all about the surfaces and the distance between them. All right, straight line vectors, rays, bits, no waves. All right, so till the next time and such, so forth and whatnot. I'm sure we're not going to get any kind of reply. Shit, the internet sucks.